Hello, I'm ETarte, math teacher. This is a solution video for my math challenge which I entitled Right Triangles. In that challenge, I presented a right triangle with altitude to the hypotenuse, legs A, B, and the hypotenuse C, A being the shorter leg. We're familiar with the Pythagorean equation, a squared plus b squared equals c squared. The altitude of the hypotenuse is what I called h, and that splits the hypotenuse c into the shorter part m and the longer part n. So I had one situation in which the shorter leg a has length 3, and then we had a harder challenge to go with it, in which the shorter leg A has length 17. I said that in each situation there is exactly one number pair B, C, in which both B and C are whole numbers, so that A, B, and C satisfy the Pythagorean equation. But M, N, and H are not whole numbers, but you are to find B and C, and then also find M, N, and H. Then after that, you're supposed to figure out with a larger triangle similar to the original, that means it has the same shape, in which all 6 of these variables are whole numbers. Well, here's my solution. In an earlier video that I referred you to, I developed the fact that we can get whole numbers that satisfy the Pythagorean equation, a squared plus b squared equals c squared, by starting with odd numbers for a being the smaller of the two legs, such as 3, then 5, then 7, then 9. How do we get the b and c to go with each odd number a? We square a, then divide by 2, and then subtract a half to get b, add a half to get c. For example, with a being 3, 3 squared is 9, 9 divided by 2 is 4 and a half, subtract a half, you get 4 for b, add a half to 4 and a half, you get 5 for c, and that is a Pythagorean triple that will be familiar to many of you, the 3, 4, 5 right triangle. For the next a, 5, 5 squared is 25, 25 divided by 2 is 12 and a half, 12 for b, 13 for c. 5, 12, and 13 in fact satisfy the Pythagorean equation. When a is 7, 7 squared is 49, 49 divided by 2 is 24 and a half. We take b to be 24 and c to be 25. They satisfy the Pythagorean equation. When a is 9, 9 squared is 81. 81 divided by 2 is 40 and a half. We take b to be 40, c to be 41. Well, the 3, 4, 5 triangle is the basis for the first of the two challenges. For the second one, we have to take a to be 17. 17 squared is 289. Divide that by 2, you get 144 and a half. So our b is 144, c is 145. And we can verify that that triple of numbers satisfies the Pythagorean equation. So we'll focus on our smaller challenge, the first easier challenge first, where a is 3. So we have a is 3, b is 4, c is 5, a 3, 4, 5 right triangle. Now how do we find m, n, and h? Well, there's more than one way to do it. One way is to consider the area of this triangle. The area of a triangle is 1/2 the base times the height. And we can use 3 and 4 as the height and the base because they are at right angles to each other. 1/2 times 3 times 4 is 3 times 4 is 12. Half of that is 6. So the area is 6 of this entire triangle. Well, now instead of having B and A be the base and height, we can have C and H be the base and height. Just as 3 times 4 is 12, C times H must also be 12. And since C is 5, H must therefore be 12 over 5, 12/5. Now to find M and N, first to find M, we can apply the Pythagorean equation to this smaller right triangle, where we know its hypotenuse to be 3 and one leg to be 12/5. We substitute those into the Pythagorean equation and we get M to be 9/5. We do likewise with the lower right triangle. To find N, we get N to be 16/5. Now we go to a larger triangle similar to this one, and we want all 6 of these to be counting numbers, not just the A, the B, and the C, but the M, the N, and the H also. Well, to do that, we simply multiply all 6 of these by that denominator 5. 3 times 5 is 15, 4 times 5 is 20, 5 times 5 is 25, 9/5 times 5 is 9, 16/5 times 5 is 16, 12/5 times 5 is 12. And so we have the new numbers, the larger numbers, where all 6 of them are counting numbers: 15, 20, 25, 9, 16, and 12. Now turning to the other challenge, where A, instead of being 3, is 17. We said earlier that in this table, when A is 17, B is 144, and C is 145. Applying the same method now as with the other triangle, to find H, C times H must be the same as A times B. Well, A times B, that's 17 times 144, is 2,448. And therefore, the length H must be 2,448 divided by the length C, divided by or over 145. So H is 2,448 over 145. We now apply the Pythagorean equation to A, M, and H to find M. M works out to be 289 over 145. Now, to find N, we can use the Pythagorean equation on H, N, and B, or we could subtract the value of M from the value of C. Whichever way we do it, we get N equals 20,736 over 145. Now we go to the much larger right triangle, similar to this one, and we want all 6 lengths to be whole numbers. To achieve that, we simply multiply each length by that denominator 145. And when we do that, we get these lengths. Our new A is 2,465. Our new B is 20,880. Our new C is 21,025. Our new H is 2,448. Our new M is 289. And our new N is 20,736. Again, those were gotten by multiplying all the lengths in the smaller triangle by 145. And there you have my solution to my right triangles math challenge. Thank you for watching this video.